Here is a particularly interesting problem. So this is the mass m1 and the big mass happens to be m2. There is no friction involved in this question at any surface. So neither this surface has friction nor this surface has friction. So we are analyzing how to write down the Newtonian and the constant motion equations of this particular system. We can understand that the mass m2 is going to move towards the right hand side as the mass m1. So mass m2 will move towards the right hand side as the mass m1 moves downwards. So the acceleration of mass m2 will be a2 and the acceleration of mass m1 will be a1. A1 acceleration can be measured from this particular rigid support, or you can say this particular point, let's say from this particular point, and A2 acceleration can also be measured from this particular point. So that way both the accelerations are measured from a rigid support. So this point is fixed with respect to this point. So you can say that A2 acceleration is being measured with respect to this particular line. This is what we can say. So in order to understand what is to be taken as x1, x1 will be something that on double differentiating will give us a1. So this happens to be x1. This much part of the length of the string happens to be x1. So for x2 it is again very simple. This much part of the length of the string happens to be x2 and this also happens to be x2. Both are varying as x2, and this much part of the length of the string happens to be constant. So this is a constant length of the string that is not varying. So no matter how the masses move, this constant part is d and it is fixed. It's not varying at all. So this happens to be x2 and x2. If we note down a constraint motion equation quickly, then we understand that x1 plus 2 times x2 plus d is the length of the string. On double differentiating, we get a1 plus 2 times a2 equal to 0. Here we need to understand that a1 is the downward acceleration of mass m1, but mass m1 is connected to mass m2 because it has got a normal reaction force over here. So I mean to say it is touching the mass m2. So since it is touching the mass m2, it will move towards the right along with the mass m2 with the acceleration of the mass m2. So for the mass m1 there are essentially two accelerations. So one is the downward acceleration a1 and one is the acceleration of the mass m2 itself, because it is rigidly connected to the mass, not exactly rigidly connected, but it is in contact with the mass m2. So it's going to move towards the right hand side with acceleration a2. So this is the analysis of the mass m1. So now let us do the Newtonian equations. Let us write down the Newtonian equations. So for the mass m2 we can write down 2t minus the normal reaction that the m1 throws back on m2. So this is the normal reaction n force. Okay, so this is going to cause the rightward acceleration of the mass m2. So this is going to be equal to m2a2. So for the mass m1 we have got two particular directions we can analyze in. So one is the downward direction. For the downward direction we can write down m1g minus t is equal to m1a1. Here we have a fourth variable, namely n. So this is one equation, this is second equation, this is third equation, and the variables that we have till now are a1, a2, n and t. Naturally we need a fourth equation. So basically we then write down the x direction or the horizontal direction equation of the mass m1. So this is the y direction equation. Let's say my y direction is this. This is my y direction as of now, and this is my x direction. So we have written down the y direction equation for the mass m1. Now we are about to write down the x direction equation. The x direction equation happens to be simple. N is the only force acting on the mass m1 in the x direction. So n is going to be equal to m1a2, because in the x direction the mass m1 is moving with the acceleration a2 because it is in contact continuously with the mass m2 whose acceleration happens to be a2. So this happens to be the x direction equation for the mass m1. Okay, so these are the three Newtonian dynamical equations, and this is the constrained motion equation. So using these four equations, this particular situation can be completely solved.